Okay. So okay, let me just quickly recap again. So
Uche, sorry.
sorry.
Sorry, Uche.
Yeah,
You
yeah.
have a link for all the videos, right?
Yes, I have a link. Yes, yes.
Okay, please, I would like to have it.
All right, all right. I will send the. At least I've uploaded the last one on YouTube, so this will come up as soon as the class ends.
Okay.
All right. So
Okay.
all right. Okay. So the like I was saying, in the last class I spent a lot of time talking about the base this task one and like some of the like basic functions we use, like the get line function, the exeve, and those sort of things. I try to like explain what each function, why each of them is important, and some of the edge cases you need to like think about, like replacing the new line with a null, you know printing, how you print the dollar sign, using write instead of read, how you check if something came from the terminal or if it came from the maybe pipe or some other way that is not the terminal. So I just try to explain some of those things, and then how you create a fork, why is a fork needed, and how do you differentiate between the parent and the child. I say a lot of things there, and you can always refer to that. So today I just want to give just explain the one how far I've gone, and how I approach my own. So how I approach. So at least I've, to the best of my knowledge, I've done number two. All these things I'm saying, there's no checker now, so I'm just waiting. What I'm just doing is, while I'm doing other tasks, I am going through each of them and trying to see if there's any edge case that I still need to handle, right? But I cannot be 100% until checker is released and I press check. So, but at least to the best of my knowledge, I've done this. I've done number three. I've done 4, and I've done 5. So I'm working on 6 now, writing get line function. So basically 2, they say we should handle command line argument. So if you were in the last class, what I did in my own program, um, um, let me open my folder. So what I did, if I run my program, what the task 1, right? What we are required to do from task 1 basically is just when you run your program, right? You should be able to call an executable and it works. So if I do /bin/ls, it works. Your program is expected to work like this on that task 1. So by then, right, from task 1, you are not expected to have, if your program is not in the current directory. So if this /bin/ls, if I do ls, right, your program is not expected to work yet for task 1. Now I spent some time in that class trying to explain how this works. Like, how is it that I'm able to type ls? How is it that I'm able to type this and it still works, even though this file called ls is not in my current directory? If I search for a file that is not here, like maybe jk something, it tells me file does not exist. But if I type ls, it works. How is that possible, right? So I spent some time trying to explain it. So basically what's happening is, when you type a command that does not exist in the current directory, right, and you can, I don't know whether pwd works. Okay, yeah, it works. If you check your current directory, right, like in this case now is your simple shell folder, right, there's no there, like ls is not here, mkdir, all those commands, they are not, the executable files are not here. So how does it work? So basically what your system is doing is, when you type a command that is not in the directory, it searches for that command in a series of folders. There is a series of folders in every Linux system where executable files and system files are stored. So when you run a command, right, and it is not in the current directory, it goes to those folders and checks each one of them to see if this file exists in any one of them. If it doesn't exist in any one of them and it is not in your current directory, then it will now tell you file does not exist, right? So that's basically what happens. So if you want to, what is the part I'm talking about? So if we do let me use the normal shell to do it. So if I do echo $path, right? So this is my path. This is the path in my this is the path from my computer. So these paths can be different for every system, right? I have some software, like for example, I have something called Anaconda. It's a kind of package that you use if you want to do Python and data science and so on. So because I have Anaconda, I have some extra path which you now may not have, right? If you check your own path now, if you run this, you may not have this Anaconda and some other things like that. So everybody's path is different, right? So but it is something that is different for every.
So
Yeah. Yeah, go ahead.
just a quick question. What this part is like the path to what?
So the path is, long story short, the path is a series of folders separated by colon here. This is 1, this is 2, this is 3, this is 4. A series of different locations in your computer where some important files, executable files, are kept, so that when you are running in the file in your terminal, right, instead of you to always be typing the full path of the file, like imagine this now, imagine I want to run this something in bin, I'll be doing /home/this/this/this/this. If you just run it, the system automatically, when it doesn't find it in the current directory, it goes and checks each of those paths folder to see if the file is in any one of them. If it is not in any one of them, then that's when it will now tell you, hey, this file does not exist. That's what path is. And you can update your paths. You can add more like paths to it. So for example, now I can just create a folder somewhere in my system, right? Maybe all my ALS projects, for example, right, I compile all my projects and I want to like I want to be able to run them in my terminal, but I don't want to always be saying /something/something, or I don't want to always like cd into the folder always. Just I want to be able to run it from anywhere. So I can just create a path and add it, right? There's a command to add to path. So like I said, this path is different for everyone. You can add a folder to this path. So what will happen is that, for example, this file now, this is my program ./simple shell, right? This is my program I created. If I do cd ... and run it, it wouldn't do anything because it doesn't exist, right? If I go to another folder that is not the current folder, it will not work because it is not in the current folder. But if I want to be able to run this from anywhere, right, so I can add this my ALX folder, this simple shell folder now, to my path, so that anywhere I am in my terminal at all, doesn't matter the folder, even if I go to cd home like this, right, anywhere I am, it still works. That's what the path is. So I don't know if you got that.
So not totally. I didn't really get it completely.
Okay, so
But I think I have an idea. But please, if you can go back one more time.
okay, so like I said, the path, right, is, first of all, every Linux system has what is called environment variables. So environment variables, they are like a kind of series of key value pairs that store information, right, on about your Linux system. So for example, if I want to know the user of a particular system, right, I can just call echo, then print a variable $path $user and to tell me the current user of the system. So if I say print env, it prints all the environment variables, and there are so many of them, right? And this environment variable again is for depending on your system. It has some hardware things, like it tells you maybe the hardware, like maybe the computer you're using, your screen resolution, the version of your operating system, your Ubuntu. So it's different for everyone, right? Even the PID, like system exec PID, process ID. So it's different for everyone. So one of the variables in this thing is called path. This is path, PATH. And this path contains, this is like a string. This is, just imagine that this is a whole string, right? One string. Now, this string is like they joined, is a series of folders that are joined and separated by column. So I highlighted that this is 1, this is another one, this is another one, and all these folders are absolute paths because all of them start from the root directory. From the root directory they go to home, then it goes to the series of folders. So if you run this on your own system, it can be different from mine. So the path variable, the path is a series of folders that is set by default in every Linux system, right? If you just have a Linux system, or Unix, let me use the word Unix, there is a series of folders, right? And those series of folders is the reason why you can type ls and it works. Why? This ls I've said, right? You can imagine ls as a file, like literally like the way I have this simple shell, the way you can compile and you create. It is a file, it's an executable file, right? And we all know that if you are running a file, right, the file should be in the directory that you are in. So if I run a file, if I say ./GHT, something like that, something that doesn't exist here, they will tell me it doesn't exist. Why? Because this GHT is not found in the directory that I am, right? So what the Linux system does is that when you type any command, right, when you type any command at all, what it does is, if it does not find the file with that name in the current directory that you are in, and it may not be this directory, it may be in another directory, there are different directories, right? If it is not in that directory, it goes and searches each of those folders. It searches each of those folders that are defined in paths. So it searches each of the folders that are defined in paths. No, let me print this path in a way that that you understand. So I created a function here that print path. So this is print path. Let me see. So gcc print env paths -o paths. So this will not compile because I need some function, split string and free vector. So I need to add my other file, split ss split string and then ss free vector. I still need some other functions, but I need all of them. Okay, this is the main function. So let me just, I'll do all of them. So gcc star.c. This has all of them, but I need to remove some of them if not, it will not compile. So if you don't understand what I'm doing, right, the basically what I'm doing is I separated my code into different I separated my function. So that's why I have many files. I have each file has a function, like I put a function inside each file. So now whenever you want to compile your code, right, you have to do gcc, then call the name of each one of your C files before you give it a name. Before you do that show and depart, you have to call the name of each file. So if you have a function defined in another file, even though the code I want to compile now is in this file called print env, this is the code I want to compile, but this code makes use of a function I created called split string, and this function is in another file, here. So if I'm calling gcc command, I need to call this file that has this code I'm doing, and I also need to call the file that has split string. Now inside split string, I make use of many functions that I also created, right? I have a function called set zeros I created, and that set zero is in its own file, which is this. I have another function called count string, word counts, which is in another file that I created. So every function you have, any file that you have your function, you must call it in your terminal. When you are calling GCC, you must mention all the C files where all your code is. So that's basically what's happening here. So if you look at the command that ALX gave us on the sandbox, on the project, to compile our code, you'll notice something. They put star.c. I explained this before. Star.c means everything that ends with C, put it. So you see, when I press star.c in my terminal and I press tab, it just populated the whole thing with all files that are C, right? This is a shortcut way. So I don't know if I've seen somebody typing all this in one by one, like typing one by one by one by one, right? So you may not know that it's possible, but this is possible, and this is the reason why I named my this is the reason why I named my files this way. You see the way I named my file, I gave it a kind of consistent naming scheme. So some are SS, some are util. Why is that? If I let me close it, I know it will give an error. If I want to get all the files that start with SS, every file that start with SS, I can just say SS star and tab. It will highlight all files that start with SS for me. So it's just a kind of fast way to highlight your file. If I want to highlight all files that end with util, I can just say util star and tab. And even if I don't press tab, if I just put util star, it's still the same thing. It's just that I'm using ZHS, so it can give me the file names automatically. So that's just by the way for anyone that doesn't know that before. So I'm trying to compile this. So again, I'm going to do okay. I know what I'll do. GCC print env. So there's something I want to show you. That's why I'm doing this. Print env. Then I want to highlight only the SS files because these my util files are just practice files. So I don't want to highlight it. So I'll say SS star. So I'm highlighting all the util files. Then I think this is all. Then I'll say dash O. Then test. Parts. So this should work. Okay, yeah, it works. So if you don't understand what I did here, you can ask. So, but basically, what I'm saying here is. Sorry, one moment. Look guys, sorry about that. My network just went off. Someone called me, so that's why. I hope you can still hear me and you can still see my screen. Hello.
Yes,
Yes, I can hear you.
All right.
Yes, we can.
Okay. So again, if you don't understand what I did here, you can ask. So I'm running GCC command. This is the file, the code I want to compile. Now I just did some code. I want to print something. I want to print the parts. So this program I wrote makes use of some functions, a lot of functions. It makes use of split string. It makes use of get env. All these functions I created myself. I just created them. So they are all in their own files. So if I want to compile this program, I have to also add the name of all these files that have this function. That's why, and I name all of them with SS at the beginning. So when I'm calling it, I don't need to write all of that. I just put SS star. So that's why I do that. This dash O is just to give it the executable name. So I've created a dot slash star. So let me run a dot slash part. So if you look at this, what this program is doing basically is I created a function that splits a string, right, based on a delimiter. So remember I told you, look at the path variable, right? This is a string. This thing now is like a single string. That's what this is, just one string from beginning to the end, right? But it is not one folder. This thing now is not one folder. It is a series of folders that is separated by colon. So one folder, then colon, then another folder, then colon, then another folder, then colon. So there are different folders and each folder is separated by colon. So I created a function that allows you to give it a string and you specify what you want to separate the string by. So it splits a string, as you can see from the name. It splits a string into multiple words separated by a delimiter. Delimiter is what you want to use to separate. So a delimiter, usually what is used as a delimiter is space. So if I type a sentence is separated by words and words is separated by spaces. So you can use a space as a delimiter, but it's not always that space will be your delimiter. Like this particular case now, our delimiter is not space. What we are using to separate is colon. So I just call the function and I pass in the string and I pass in what I'm using as the delimiter. So this number here, it's just what I created to store the number of words that it finds when it separates. So then I'm using a for loop to print each one. So that's just what's happening here. Why I'm showing you this is I want you to visualize and see it clearer, right? It's difficult to see it like this, yeah, but this is what your part is. This is literally it. This is your part. Like in my own system now, these are all the folders in my part now. I have this one, home, Kofkan, Anaconda, this Anaconda, cargo bin, local. These are all the folders currently in my part, and I can choose to add more, right? In fact, there is one of the tasks that say we should even implement the feature to add to environment variable. So, but this is a better visual. I just created a function that just prints it, so just for you to be able to easily visualize it. So, like I said, a part is a series of different folders, and these are folders. They are not. This bin is not a file. Bin is a folder. Bin is a folder. It's not a file. So when you run something like ls, the system goes through each one of these folders and look for ls inside. If it finds ls inside any one of them, it will run it. Basically, that's what it is. That's what happens, and that's why I'm able to type ls without putting /bin/ls, right? And this thing I explained now is what we are told to handle in task 3. They say handle part, right? So if you look at the example from task 1, where is task 1? This is task 1. When they typed ls, it shows no file or directory, right? So why? Because task 1 says you don't need to handle all those things, right? Let it just be. But when they put /bin/ls, it works. As you can see in their task 1, it works. If they put this /l, it doesn't work because it doesn't handle extra arguments. So this task 1 is simple, right? But when you are now getting to task 3, right, they say you should handle part. What they are saying now is that if you put /bin/ls, it should work. But if you type only ls, it should still work. That's what they are saying. If you type ls, it should still work. So you should handle parts, right? And that's why I've spent my time trying to explain how this part works, because this is exactly what you will do. This is exactly what I did in my program, right? So it's depending on how you want to go about it, but that's basically what you are doing, right? You are going to take the file first of all. Like, let me now show you just the way I implemented it in my code. So some of you may have already done it. If you have a different way of doing it, it's also okay. So what I just did is, and there's an instruction they gave here on number 3. They says fork should not be called if the command does not exist. So remember that we call fork to create a new process so that we can execute. So in the previous class, right, the way I wrote my code in the previous class, what I did was I called fork, which is here. I called the fork program to create a new child process. Then I now called my execute, right? It is inside my execute program that I now checked to see if the file exists, right? That's what I did in the previous class. But what they are saying here is you must not call fork if the command does not exist, which means that we must check if the file exists first before you call fork. That's what they are saying. So what I just did is, before I came to this place where I created fork, I have a check if the file exists. So I have to check first if it exists. So I created a series of functions for that. There's a function called check file status. So this one basically it uses what it just does is to use a function called start to check if a file exists, right? I explained this function in the last class, I think. Yeah, I explained it, so maybe you can still fetch it. Though if you have any question, you can still ask me. So basically, just checks if a file exists. If it exists, it returns 0. If it doesn't exist, it returns I think -1 or so. So now this function, this start function, right, takes in a path, right? So if I type ls, right, it will pass this ls into the function, right? This start will check if it will check this directory, right? And because I typed ls, right, like this now, because of I just typed it like this, it assumes that I am looking for ls in the current directory because I didn't put / anything. I just said ls, which means look for this thing in the current directory, right? That's what this thing is doing. So it checks and it sees nothing. It says, hey, this does not exist. That's why if I run it in my that's, I mean, if I run a command that is not here, for example, if I do lkf or something, right, it says command not found. Why? Because I provided the part of the current directory, and I'm saying, hey, look for this thing in the current directory. It's saying, oh, it's not found. So what I just did in my program is that if you check and you did not find the file, that's why I put not. This exclamation mark means not. So at v0, okay, first of all, I've changed the code a lot from the last class. So basically what I'm doing is, you may remember where I after the getLine function, I replaced the last character, the new line character at the end, with not terminator, right? After this, what I did is I split the arguments into separate strings. So remember, anything you type on your terminal, right? If you press enter, it goes to std in standard input, and it goes as a single string. So when you call the getLine function, it reads everything as one string. So quotation at the beginning, quotation at the end, it is one string. But we cannot do anything with the string if it is as one, right? We can't do anything. So the first thing we must do when you pass your program is to separate the string into words. That's why I created this function. So this function is very important. Even if you don't have time to create it, if you have done the previous project, one of the we have done a task sometime in malloc, or either in malloc or more malloc, where they told us to create a function that splits string. So you can refer to that and just tweak it to make it fit your project, if you want. So basically it splits a string. So we need to split this string. We need to split whatever. So if I type ls-la, right, it needs to split it so that we'll have ls separate and we'll have -la separate. We need to split it first. So I just call the function that does that. So my function, what basically it does is just because if you are splitting a string, right, you are creating multiple string, which means you are creating a list of strings, right? So you should know that a list of strings in C is a vector, is a 2D array. A list of strings is a 2D array, and there is a way you handle 2D array whereby you have to allocate space for each of the array, each of the string, and then if you want to free it, you cannot just call free on it. You have to use a kind of series of if like for loops. You have to use a for loop to go over each of them and free them one by one before you now free the main thing. So there's a way it is. That's why the code is a little bit complex. So if you have time, again, if you have done the previous time, you can just get your code, just test it, make sure that it works well, then you just copy your code and take it. So that's just what I'm doing. So in my code, I just call the function. It splits all the arguments into separate arguments, right? And the first argument should always be the executable you want to run. So ls now is an executable. I can call mkdir, then give it a name of a folder, for example, right? So this mkdir, the first argument must be the executable. Then the others, they can be multiple arguments, right? So like when I was trying to do gcc alx, maybe alx.c -o, all these extra things are argument, but the first one that you run is the executable, right? It must be. So when I split the string, right, now I have a vector which contains different string, where each of the string is the argument that I passed. Then now this is just okay. This is a function. I'll come back to this. I'll come back to this one. So because this is for the later task. So here I now check arg0. So why I explain that is so that you understand what I mean by arg0. So this is the array that I created when I split it. Then I'm checking arg0, and arg0 is the first argument, which is the executable. So that's why you're seeing arg0 everywhere. I'm just calling the first variable from my what I passed, I split. So I'm checking if it exists. If it does not exist, right? If it does not exist in the current directory, what my code is doing here is check the current directory. If it doesn't exist, then what I need to do now this part is I don't know how you see it, whether it will be overwhelming to you or something. I spent a lot of time to do it this way, and I just did it like this because since ALX has restricted us from using some specific functions and basically they have restricted us from using some specific functions. So I just, this is the way that I thought about it. So the last class somebody was giving a suggestion on how to do it without like that. So I tried to check and I couldn't find any simpler way, right, to do it. So that somebody asked this question towards the end of the class, that how do I plan to check this in part. So remember I explained that this ls, right, if I run it, the system will check for it in the path. It goes to the path, and I showed you that what that path is. These are the path folder. So it goes to each of these folder and looks for the files. So this thing now is what we need to do. Like you need to do it, and that's what they are saying in this task tree. Say handle path. So they want us now that when you type a command, right, if it can't find it in the directory, then let it go through the path variable. So we need to implement that, right? So there are many things I did, there are many things that are involved. I wish if I had time I would have wrote some kind of pseudocode so that you just understand the flow of what you need to do each. So basically, if you want to search for the path, right, first of all we need to be able to get the path in our C program. We need to be able to get this path variable in our C program, right? How can we get this path variable in our C program? How can we write a function that can give us this path? And remember, path is different for every system. I cannot just create a string now and just copy and paste this code, because this my path is not the same thing with your path. So how can we get this in our code, right? So if I go back here, I created a function called getEnv. So this function, basically what it does is you specify the variable. So again, let me show you these are the environment variables. I told you guys that these are environment variables in our system, right? And every Linux system has environment variables, and you will see a pattern with these environment variables. All of them have something at the beginning. They are called key value, right? That's the term we use to describe it, key value. If you know a little bit of Python, you'll be familiar with the term. So key value, the key is the first before the equal to. So we have something equal to something, something equal to something, key equal to value, key equal to value. And if you look at all of them, their key are in capital letter. Then the value we have equal to, then we have something. So we have key equal to value. So this key is the name of the variable, right? And then this is the value of the variable, and we have many of them. Key equal to variable, value, key equal to value, key equal to value, right? So when I run env, what I'm just doing is I am printing this env command, right? It's the same thing as print env. If I run env, it does this. If I run print env, it does the same thing exactly. So both of them are doing the same thing. So what it's just doing, it is printing all the environment variables. There are many variables. It is printing all of them. But now, if I want to print only one of these variables, like one specific one, for example, now let me just call something like this. Look at this thing, say conda prefix. There's a variable here called conda prefix, and look at the value, home, Kofukan, anaconda 3. I want to print only this variable. What do? I just say echo dollar conda prefix, conda prefix, right? And it prints it for me. So this is how I can just specify the variable. So I'm doing all this in my shell. How can I do it in my C program? There's a function. First of all, there's an inbuilt function called getEnv, and what it does is exactly like this. You call the function, you give it the name of the variable, the variable that you want. So the way I wrote this conda prefix, I can put conda prefix here inside this, and it will give me this value. I can put user inside, it will give me user. Any of these variables here, you can just put it and it gives you. So the variable we are concerned with now is path. And look at path. Path is here. This is path variable, and this is the value for the path variable, right? So I want it to give me this string from here to here, right? I want it to give me this string. So when you give it a path, it gives you the value, which is this path, and this is what we need. Because again, what are we trying to achieve? We want to be able to look for our executable files inside each of these folders. So I pass in the path into the get env, and it gives me this value. That's what it's meant to do. So this one is a custom one I created, right? There's some logic behind it. So I don't know if there's time to explain this. There may be no time to explain this now, but if you want me to explain this, go ahead, but let me just move ahead for now. But if you want me to explain this, I can explain it, no problem. So but everything here is custom function. I use my own custom string length function. This one, this function count the length of a string. Then this is string compare. So what this does is it compares two strings. You specify how many characters of the string you want to compare. So this function is very important because this is the function that you use to know what is entered on the terminal. So later there are some tasks where they say handle exit, implement exit, they implement env. For you to do these tasks, right, what you need to do is you need to have a function that after you use your getLine to read the terminal, right, the function will read the first specific characters. So for example, now if I say handle exit, this is my handle exit. Okay, let me go to the shell. Sorry, I'm going back and forth. I'm just trying to, I hope the way I'm going about it is not maybe confusing, because it seems like I'm divided, but if it's confusing, let me know, please. So
It's confusing, it's confusing.
okay.
Keep going.
All right. Okay, let me. I need to follow this in an order. Okay, where did I stop that? Before I started diverting. Let me see. I was talking about this check file status. Okay, so remember the objective now, because you have like different things you're checking one by. So our objective now is we want to look for a file. So if I type a command, in my terminal, right, and this command is not in the current directory, I want my program to go and look for this file inside the path. I want it to go through each of the folders one by one and look for it and check if it's there, and if it finds it in any one of them, it runs. That's the problem we're trying to solve right now. That's the objective now. So that's everything I'm explaining now is in line with that. So I have a function that checks if the file is in the current folder. Again, anyhow you want to do it, you may not need to make a function because it's just few lines of code. You can just write it there. The main thing behind this function again is the start function. So if you check the start on the man page, you see that start takes in a file name or a path name. That's why I put path and check if it exists, right? So if I pass ls into start in this folder, it will tell me file is not found. But if I pass /bin /ls into this path, it will find the file. It will return 0, meaning the file is found. So that's what I'm checking that first. Then if it doesn't exist, then now I want to you see I have a function called check file in path. So what I'm just saying is, if you cannot find the file in the current directory, then look for the file in the path. So that's just what I'm doing here. I'm looking for the file in path, and this check file in path, now that's the function I want to now explain. So what is this doing basically? Now let me try to just give the pseudocode, because of course there's a lot of code here, but it's important to understand the flow of what I am doing, right, to get this. So now, like I said, we need to first get the path. We need to get this part echo $path. We need to get this thing inside our C program as a string. We need to get this inside our C program as a string. So therefore, I created a character pointer called current path, and I called my getEnv function, and I pass in path. So what I'm saying is, hey, go to all the environment variables among all these things here, among this long list, give me the one that is for path, which is this. Just give me only path. So when you call it, again, this is the custom one I created, but it's basically the same with the original one. When you call it, it goes through the path and gives you the strings, this environment variable path. Now it returns it as a single string from the beginning to the end, because as you can see, this is just one string. It returns it as a single string, and I store it here, right? That's what I have. Now the next agenda, now that I have this as a single string, remember that I told you this is not one folder, this is a series of folders separated by colon. So I need to split this thing into different parts. I need to have each of the parts separately. So I call my split string function. I give it the part, and I give it what I want to use as delimiter. So this one now is just a integer buffer I created that stores the number of parts it gets. So it's just something I did because I need to know this number when I want to free the part. So another thing you need to know is that this part, right, this function I created, again, when you are creating a double array like a vector, right, you are allocating space, and when you finish doing what you want to do with it, you must free it. You must free that vector. So in order to free a vector, you need to know how many how many pointers are there. So I want to believe you understand what I mean by vector, like you understand like the structure of a vector. So a vector, in this case we are using string now. You can have integer vector, but we are using character vector here. So a vector basically here is a pointer to a series of pointers. First of all, if you have a normal string in C, like if you have something like hello world, right, like if you just have a normal string in C, right, if I want to put this in store it, I will do something like char star, then give it a name. Char star, maybe str is equal to this. That char star is a pointer, and that pointer is pointing to the first letter of this string. That's how normal pointer works for a string. Now, so which means to identify a word, right, to identify a string, you need a pointer to identify a string. Now, what if you have 10 strings? Each of those strings has a pointer that points to them. We have 10 strings, and each of them has a pointer, which means we have 10 pointers. So if we want to have a list of those 10 strings, it means it will be a list of 10 pointers. It will be a list of 10 pointers. So that's what a vector is. So a vector is a pointer to a group of pointers. So you have a pointer, and that's why we put double star. So you are saying the first star means it is a pointer. The double star means it is a pointer to a pointer. So it is pointing to the first pointer. So imagine we have 10 strings here, right? This one is just pointing to the first one. But you can now use pointer arithmetic to go through each one. That's just what a vector. So it's important for you to understand this in case you don't understand. If it's not clear, let me know. I'll still explain it. So that is what a vector is. So now, when I create this, when this function runs, it splits the strings into, it splits the single string into multiple strings, right? And it is a dynamically allocated array, a dynamically allocated vector. That's what is returned. So now that I have split it into multiple strings, it is going to come, it's going to be somewhat in this format that I showed you guys, right? Excluding this number and hyphen. I just put this number here just to make it easier to read, but this is how it's going to be basically in this thing now. I just split them, so instead of it to be joined like this, it's now like this. So now I have my vector, right? Now I want to go over each of the parts, each of these ones, one by one. I want to do something. I want to go over each of them and do something. Now, what is the something I am doing? You know, C is a very, very manual language. It's so manual. This thing took me almost 1 day to write. But if I want to do this thing in like Python, I can do it in like 3 minutes, literally. In fact, 3 minutes is too long. So C is just so crazy. What I did here is I took the first string, like I created a function, another function, strs concat. What this function does, right, is it takes in multiple strings and joins them together. That's what it does. Simple, very simple. It takes in multiple strings and join them together. So if you have 1, 2 or 3 or 4 or 5 strings, it joins them together. So if you heard what I said now, it takes multiple strings. I made this function as a variadic function. If I go to str concat, so that's why it took me time. I made it as a variadic function. So it takes in multiple arguments. So this function now, the way I wrote it, it can take in, you can join 10 strings, you can join 15 strings, you can join 20 strings, any number of strings. So the reason I did this is because what my objective here now is this. I want to look for ls. or any folder that is entered on terminal. I want to look for it inside each one of them. And in order for me to do that, I need to concatenate that command with each of these string one by one. So you know we have /bin/ls. Now here we have /bin. We just have /bin. And we know that ls is in this folder. We know that ls here. But in order to find it, we need to add /ls in front. So you need a function that can join two strings. Again, there's function. We have str concat. There's inbuilt function, but it's not really among the mandatory functions. So it's not really among the allowed functions. So that's why I created my own. So we need to concatenate that ls with bin, right? We need to concatenate it. When we concatenate it, we will now have the full path. That is why I named my variable full path. So if you see here, I say full path. What I'm just doing is I am concatenating each of the paths. So I have a for loop. This for loop is going one by one, one by one. So take the first one, right? At the end of it, put slash and put the command that the person type. If it is echo, put /echo. If it is cat, put /cat, something like that. I'm just trying to concatenate it, right? Now, what you type in your terminal, if I say echo, echo is what is the command I type. I did not put /echo. If I put /echo, it means I'm trying to maybe go into a folder or something. I did not put /echo, I put echo. So now, and look at the irony now. The inbuilt function, there's a function called str concat. If I go to man3 str concat, I don't know if this is it. Busy str underscore concat. I don't know the exact name. Anyway, there's a function. There's an inbuilt function. Wait, let me see if I can get it. str concat. Okay, this is the one I created. Anyway, there's a function inbuilt in the program, so maybe you can check it while I'm discussing. There's a function that joins strings. Now that function can only join two strings. The inbuilt function, the one from the standard library, it can only join two strings. So you can specify the first string and the second string to join. But in this case, right, I need to join more than two strings. I need to join 3 strings. I need to join the path, something like /home /bin. I need to join, this is the first part, like for example, then I need to put slash, then I need to put the command that the person types, so maybe mkdir. These are the 3 things I need to join. Remember, what you are typing is the command. This is what you are typing. This is the part I'm getting through this, but I need to put a slash in between. That slash in between is important. So because of that, even if we are allowed, I cannot really use the inbuilt function from the library, because if I want to use it, right, I have to call it 2 times. I'll say join this and this, then when I join it, then I'll now say join this and that again. So I just made my own to be like variadic function, where you can pass in multiple arguments, then you pass in how many. So because there are 3 things I want to join here, I put 3. So it joins, it gets each of the parts one by one, join it with add slash in front and add the command name. So it will now give you the full path. So it will now be something like /ls, something like that. It now gives you a full path, right? So that's why I just have full path. Now when this function gets the full path, when it makes it a full path like this, it now checks again. So we have check file status, which is that first function. It just calls the start function and check if the file exists with this full path, right? I added the path in front and then check if it exists. Now if it exists, right, then return the path. That's what I'm just doing. If the file exists in that path, return the path. So if it doesn't exist, this for loop will exhaust then to free all the vectors. So you see a lot of free here. To free all the vectors and then return null. So this is what I did. This is what I'm doing here. This is just the way I went about it. So again, it's, I didn't explain some of the function, but I'm just trying to give you like the flow of how I went about it. So I don't know. I want to continue. Is there any question or any part that is not clear on that? Or any suggestion?
Yes, I have a question.
Okay.
Sorry, Richard, I have a question.
All right.
I have a question.
Yes.
Can you hear me?
Yes, I can hear you. Yes.
Okay, my question is the first one is please, how do you name your files? I know I'm used to this what is it called, split spring ss slash dot abc dash or what,
Yeah, yes,
hyphen split spring
yes.
ss handle. And how do you name your files? I've seen them before, but I'm trying to know how you name your files. And
Oh,
these are what are the rules? The second one is what are the rules? How do you, like, when you type a function, you
yeah,
understand, you have rules before that things you're to type,
yeah, yeah.
and there's some things you're supposed to type.
Mm,
How do you know what to do next? Because when I'm trying to, do
mm,
my own or code,
yeah.
they tell me what to do and what not to do. They tell me where to type and where not to. There are some
Okay.
rules to this. I don't know them. Please, can you just
Okay, okay. So
give
the
them to me?
naming
Thank
of
you.
my files, is just I would just say it's a thing of practice. Is maybe the more you code, you just like have it's like a habit. So first of all, I generally, even if I don't have like a way I want to like, even if I don't have maybe a system I want to use, even this SS I'm naming, I may decide to change it later. Like if I have, I started with util, then later I say, oh, let me call it SS. SS means simple shell. So I may decide to change it. So it's the main thing is, like I said, let it be consistent. And one of the reasons I told you that I name it like this is because it makes it easier for me to highlight it on my terminal. So another thing I use to like know the, well, I say have a naming scheme for my file is what the file is doing. So if my function is a kind of boolean function that checks like is something true or false, right? I can name it check. If it's something like true or false, then if it's something that like maybe handles a specific, for example, now in the project here they said implement the built-in exit. Here they said implement handle path, implement exit, implement env. So all these things have different ways. So I gave this one handle env, I gave this one handle exit. So then anything that involves like string, joining string, I gave it str. So it's just a, there's no real one way of doing it, right? And there's no right or wrong way, but it's just to write your code in a way that makes it easy for you to understand it when you go back to it. So this the same thing with the function names. It's the same thing with function names, just to write it in a way that goes. Now, your function, right? If you understand what a function does, like the flow of a function, right? A function takes in input. A function is like input output. It takes in data and it gives you data. You give it information and it gives you back information. That's literally what a function does. So if you understand it like that, you'll now be able to know, okay, if you want to create a function, because I know this is like a very hard skill, like it's very hard. Like, it's when you are writing code, like you just feel like, why can't I just write my code one line from top to bottom, right? Imagine if all these things is in just one file, right? It's going to be crazy. So like if you are still learning, like it's difficult. How do I separate it? Which part will I put in this? Which, even me, I struggle with that. Like it takes me time. Some of this, it did not come to my head. I have to like think, should I do this one like this? Should I do this one like this? Even now, say if I still have work to do, if I call Betty on my um if I call Betty now on my project so far, you see what Betty is complaining. Betty is saying I have more than 40 lines. So some of my functions are very long. Betty is telling me they are very long. I need to separate it into more functions. That's what he's telling me. All this thing now is telling me too long, more than 40 line, more than 40 line, more than 40 line. So I need to separate it, right? And this is one of the big work. Sometimes like this alone takes me time. Like, okay, what part of the code? Betty now is telling me that this code is too long. Yeah, this one. So I need to pick some parts here, like maybe like here now, and bring it out into a function, right? So it's like I said, you have to, a function takes in input and gives output, right? So you have to like think, okay, what are you going to pass into the function? What does the function need, right? And then you write all the code inside that the function needs to do, and then what does it need to return, right? The return value is what you use inside another function when you are calling it. So for example now, I have a function that check file status. This function, this first one that is check file status, this function is a boolean function. It returns true or false. That's what this function does. And The result of this true or false is what I'm going to use to perform some action here. So I create a function, I give it bool. This check file status is a bool. As you can see, it returns boolean. Boolean means true or false. So I give it some things, then based on whatever it finds, it will either return true or it will return false. So whatever it returns, right, to the program, I can now say, okay, if the thing is true or if it is not true. In this case, I'm checking if it is not true. If the thing is true or if it is not true, then call another function. The function, what a function returns again, is what will determine what I'm going to do. This check file part now, this one is a function I created, and what this one returns is either it returns the part of the file that I found, or it returns null. Simple. So if I type home, if I type ALX, for example, now if I'm looking for a file called ALX, right, and I search, the function will take this ALX and append it, concatenate it with each of the home variables, each of the path variables, and check if it exists. If it exists in any one of them, it will return the full path, like the full path. So instead of ALX, it will now return /bin/ALX or /home/something/something/ALX. It will return the full path. That's what I did. I made this function to do. So if it doesn't find it in any one of those places, it will return null. I set it there. That's the way I wrote my function. It will return null if it does not find it. So either it returns the full path or it will return null. So based on what it returns, right, I can now make my decision. So here I'm saying if not full path, which means if full path is equal to null. So this is just how I like to write my code to make it short, but it's the same thing. If full path is equal to null, you can write your code like that. If not full path, then print an error and free the vector and continue. Continue means skip all this remaining process in this loop. Remember, we are in a while loop. So continue means skip every other code here and just go and give the user another prompt to type on the terminal. Skip all this, because if I type ALX and it doesn't find it, right, it shouldn't be creating a fork. It shouldn't be executing. It shouldn't do anything. There is nothing else to do because what you are trying to execute does not exist. So just keep everything and just go to the next. So that's why I put continue. So I don't know if I know this is not like very explanatory, but I don't know if like maybe it gives you some kind of insight. So like, the long and short of it, like it's a thing of practice. Like there's no maybe one way, it's just something you just practice. And even though you see it like it looks easy the way I'm explaining it, but I spend a lot of time like thinking about it, like should I do it like this, should I do it like this, so it's just something that comes as you practice. So I hope like that maybe gives some insights. Or do you have another question?
Okay.
Yeah.
Yes, I have another question.
Okay.
Yeah, I did justice to the previous question I asked.
Alright.
The function, do we have any file that contains all the functions we can use in this ALX stuff, or maybe coding software engineering? Like, is there a way I can get all the functions and all the rules on what to follow, how to do that? If I want to create my code, you understand, or I want to do what I want to do, I want to code, I can just do my own.
Okay.
You don't have a way creating maybe shortcuts. Instead of writing all this long thing, sometimes I'll like, how can I cram all that? Can I read all these things? It's not easy, and I think it's not possible. I'm just going straight to the point. You understand?
Yeah.
So if there are rules to this, definitely you just write one sentence, one line, then go down to your result, and they are good to go. And bet it will score you. That's what I think. I don't know if it's possible.
That
There can be a shortcut to this.
Okay, to put all your functions in one, will I say one place?
Or your functions, or your code, or whatever you are doing,
Yes.
or whatever tasks or projects you are doing.
Yes.
There's a shortcut to writing your code.
Okay. So there are actually many shortcuts. So there are many ways. There are many things I do. Like maybe I'll just be mentioning it, little by little. So, it all depends on like how you want to, let's say, make use of all the things we have been learning in ALX, right? So there's something I'm using here called makefile. I don't know if this is relevant to your question now, but maybe I'll just use this to explain it. So some of you may have heard of this, but what this is and what this makefile is, if you see, there are some things you see me doing. If I do make SSW, what I just did now is to compile my project now. That's what I just did now. If I want to run Betty on all my files, I just do make Betty all, and Betty will run on every single one of my file, right? So what is happening here is that this makefile, right, is like a shell file. You know how shell script is. So you know, in a shell script you can write your different Linux command, then you now make it executable. Use chmod to make it executable, then you now do / the name of the file, right? So the thing about shell file is that if you write many code in it, like if you write 10 things in it, like you cannot specify and say, oh, I want only line 2 or 3 to run. If you run a shell file, every single code inside the shell file will run. But what this makefile allows you to do is it allows you to give shortcut to a command. Now this is the command that I'm using to compile my code. This is the command here. Ideally, if I want to compile my code, I'll write gcc s something star.c this dash g, everything. I'll put everything, I'll write it out long. But instead of me to write all these things out long, I just gave it a shortcut called ssw. So if I do make ssw, it will do the same thing. Not only one command, I can put many things. I can put, if I have a series of things, right? There's one of the previous project they gave us on a file.io, where we are told to do elf file. So if I go to the makefile of that one, I've been using makefile for many of our projects. This is a makefile I created for one of the projects. I set different commands. All these things, look at this cat, echo cat, wc, different things. If I just run only this command here, it runs everything for me once. So it's not hard to learn at all, literally. If you look at this, you can even learn it in like 30 minutes. Just go online and check how to use makefile. It's very easy. So if you write code a lot, you know, it helps. So I have a like, if I want to compile task 1 now of this project, I'll just do make task 0 and it will run the command to compile it. If I say make task 1, it will run the command to compile it. If I say make task 2, it will run the whole command. So it just makes it faster. Instead of me to be doing copy and paste or be writing, I'll just create the file at the beginning. So again, this is not hard. This is one of the ways I used to just increase my productivity when I'm working. So for the files, right, if it all depends on, again, like you can just create a file, a folder, and put everything there, right? And if you want to even go far, right, you can, remember I told you that you can add to your environment variables. So you can just maybe create all your executable files, put them in one folder, and then add that folder to your environment part, so that anywhere you run it from, it works. So there are different ways, you know, there are so many ways. If I start talking itself, like, there are so many ideas, you know, it's just exploration and just how you want to, you know, go about it. So there are some other things, but maybe as it's coming to my head, I'll just be mentioning it, right? So like I said, some of these functions, for example, when I wanted to do this str compare, the first one, I know that ALX has given us the function before. So depending on what you are using, right, I like me now, you can see I'm using a special editor. This is still Vim, but it's a higher version of Vim. So I can do some things. I can search in files. I can say strcmp. I can search for a file. I can do some kind of thing. I have syntax highlighting and auto completion, right? Even if you can't use this, you can use VS Code. Let's see VS Code. VS Code still does the same thing. So anyone you want to use, right? As far as you know that you know how to use Vim. So there are different things you can do to just, you know, increase your productivity. So as it's coming to my head, I'll still, you know, explain it. So again, if you have questions, you know, feel free to.
All right, thank you.
All right.
Thank you very much.
All right. So, so now we, you know, I've explained what I'm doing here, right? So again, what am I doing? First of all, the flow. I'm just explaining my code, you know, because I don't want to, like, I don't want to impose my code, because there's a way you look at it now, you may not be able to think of another way, you know. So I'm just giving you my flow, then you may have a better way of doing it, right? Some of the things I did may be redundant, you know, but it all depends. So basically, I am checking if the file exists. If the file does not exist, right, it will do something. But if the file exists, so if this thing is actually true, right, if the file exists, all this whole if statement will not work, will not run. Now, look at the thing. There's something I did here. If I type a command like let's say cat, or let's say maybe I want to compile my code. For example, if I type gcc test.c alx.c, for example, maybe shell.c, then dash o, maybe test, for example. Now, right, let's just say this is something that I type in my terminal, for example, right? You know, like I said, this goes into your standard input. The getLine function, we read it as one string. This is one string, right? So we need to split it into separate strings. So I call a function that splits it. When I split it, right, this GCC will be a single word. This test will be a single word. This will be a single word. This will be to separate it into individual words. Then it takes the first word of this string, which is 0. The first word, in my case, I call args0. It takes the first word and checks if it exists. Now look at the thing. If the file exists, right? When I call my function, if the file exists, it returns the full part of the file. So if it finds GCC somewhere, right? GCC may be, because GCC is not in my current folder. Now, this GCC is not in my current folder. But the reason it's working is because GCC is in one of those folders that are in the paths. It's one of them. So if you can't find GCC here, right, go and check each of those paths. If you find it anywhere, return the full path. So if it is /home/bin/something/gcc, return it fully like that to me. So now my function either returns the path or it returns null. If it returned null, that's why I put not. This exclamation mark means not. So if the full path is not found, which means the file does not exist, print an error, free the vector that you created. So this split string, right, I told you it returns a vector. And when you want to free a vector, you cannot say free vector. You cannot just call free, because a vector, I told you, is a pointer to pointers. So you have one pointer that is pointing to many pointers. It may be 6 pointers, it may be 7 pointers. You have a pointer that is pointing to many pointers, and each of those pointers is pointing to a string, a word. So for you to free a vector, if you have done the previous project, this is familiar to you. You have to free each of those dynamically allocated words first before you can now free the main vector. So because of that, I created a function called free vector. So free vector just we have done it. It's just a very simple thing. It just goes over each of the array element and frees it. Then when it frees, it now free the main vector itself. So that's just what I'm doing. So I free the vector, right? So if the path does not exist, just free the vector, then continue, go to the next loop. But if the path exists, that's what else means. Else means if the path, if you look for the file and you actually find the file, right? What I want to do now is this. Remember, I have a vector that has split this into individual words. I have split all this into individual words. Now, if GCC is not in my current folder, but GCC is in one of the paths, GCC is in, for example, GCC is in /bin/home/something/GCC, is in that folder, and I've returned the folder, right? I need to replace this first argument, this first vector. I need to replace this GCC now with the full path. I need to replace this with the full path, because this, if I pass this thing like this into my execute function, it will tell me file not found because GCC is not in current folder. So instead of passing this, I need to still pass it, but I need to return the full path now of this GCC to it. So how do I do that? Remember that this vector is a dynamically allocated vector, which means that each of the words is dynamically allocated. This GCC, malloc was used to create space for GCC. Malloc was used to create space for ss-star.c. Malloc was used to create space for this simple.c. Every single word here, there is a for loop. I use a for loop to use malloc to create space for each one of them. So what do I need to do to replace this GCC with the full command? Simple. I'll free the first one. This first part, this is a string, this is a dynamic, only the first part, I'll free it, free arg s0, which means set it to null. When I free it, then I'll now say arg s0 is equal to full part. That's what I'm doing here. Replace the first argument with the full part if it exists. So that now, from here, now instead of it to come like this, it will come with GCC, the full part of GCC. So that's what I'm doing here. I free that first argument, because again, that first argument is a dynamic. If you don't free it, it will not work, because the args, right, this first part, malloc allocated 3 spaces to it. Malloc allocated 3 spaces, GCC. Now what I want to store in it is /home/this/this/this/this. I cannot store it in this space because it only has 3 spaces. So if I just say args equal to full part without free, it will have error because there is not enough space. So I need to free it. Then I now say, okay, now that you are free, you are pointing to null. I now point to this guy. If not, there will be memory leak. So that's just what I'm doing here. So if you have questions on this, you can ask me. So after that, then I now do the remaining stuff. I create the fork and go about executing. So I believe I've explained this in the last class, so maybe I may not spend too much time, but if there's any part you still want me to like explain, just feel free to let me know. So that's basically what I'm doing here. Now let me talk about something which is freeing your dynamically allocated memory. So whenever you use malloc or realloc, right, you have to have in mind somewhere that you need to free your memory. You have to have it in mind that you need to free one of the instruction here, and this is something that will make a lot of people's check to fail, is that where is it? They said that your program should not have memory leaks, right? This thing is one of the things that will make a lot of people's check to fail, because you may write your code, but you did not handle memory leaks. You did not free the memory when you are supposed to free it, right? So you need to know how to free your memory whenever you use it. And I don't think you can avoid using malloc in this project. I'm not sure if you want to, even if it's only the mandatory task you want to do. I think at some point in time you will use malloc in your code, so you have to worry about this. So now in my code, right, I'm just trying to give you an idea of, so that you know when to free, because this is a big question. I had a long conversation with ChatGPT just trying to explain, when do I free this thing, when do I free this, right? Now in my code, there are 2 places in my code now where I create a dynamic array. There are 2 places in my code where I do this. First place is in this args. This args, this split string splits my string into multiple words and stores it in a vector, and that vector is dynamically allocated, which means that if I just run it and use it and close my program, there will be a memory leak, because I need to free this thing. I need to free args somewhere in my code. I need to free it, but I cannot free it before I use it. And this args is going to be used inside my execute function. I have a function that calls execve and pass it. So I cannot free that memory before this place. If I free it before here, this will not work. So I need to allow this guy to finish. So, but remember that this execve consumes your program. It does not return. It ends. It does not return. If you call this thing, it does not return. So how do I free my memory? Because I'm passing in something. Like, imagine you give somebody something and the person does not come back again. The person say, I want to travel. And you are expecting that when the person comes, he will give you back, but the person does not ever come back again. How do you free it? It's almost the same thing here. So basically what I'm doing is, after I call my function, right, if the function fails, remember execve does not return. So if the function fails, this code will run. But if the function succeeds, if this execve succeeds, then all this code will not work, because this execve does not return. So this code here will never work. So that's why I didn't use an if statement. Normally I would have said if execve equal to -1, something like that. But here you don't need any if, because automatically anything that makes the code to get to this point, it means execve failed. Why? Because execve does not return. So that's why I didn't put if. Hello? Hello? What's wrong with my network? Can you hear me? I don't know why my network just went off. You can hear me, right? My network just froze a little bit.
I can hear you now.
All right. So you get what I was saying about this, right? So basically, if this function fails, if it doesn't execute the program, right? Now, first of all, let me start again. Now, I have throughout all my code up to this point, right? I've not allocated any memory. I've not dynamically allocated any memory. So I don't need to worry about freeing anything, right? If you don't dynamically allocate any memory, when your program ends, all the memory is freed. So, but here now I allocate a memory in the heap, and this is dynamically allocated, which means I have to handle to free it. Now, this is one memory which I've allocated. This is one. Now, somewhere later, I call a function called check file in parts. This is my second function, which creates a dynamically allocated memory. This function, like the way I did it now, it uses malloc to create space. So for me now, in my own code, this is because I understand the code that I wrote. I have two functions here. I have two places where I've allocated memory. This full part, this place, and this args. This args is a vector. It's a pointer to pointer, so it's a double pointer. But this full part is a single pointer. It's just a string. It's just a dynamically allocated string. So if I want to free this full part, I can just say free open bracket full part. Right? If I want to free this one, it's just one this thing. But if I want to free this guy, which is a vector, I have to do some for loop and free each of the. That's why I created a function. Now, I need this split string. I need this so that I can pass it into my execve function so that it will execute the command. That's why I need this. So I cannot free this memory before that place. But this full part, this file part, I also need it in case it is found. I also need it there. So basically what I'm doing is this. I've created a memory somewhere, right? I now say, okay, I here now I'm checking if the file exists, right? If the file does not exist, like if I type a command, so again, this is because I understand my code. If I say /als, for example, right? Let me run my own program. If I say alx, for example, just a file, right? By the time I press enter, right, the code is going to run up to this place. It's going to run up to this place. In fact, you know what? I have an idea. Let me see. I have an idea. I just realized something yesterday with VS Code. It's easier to visualize this here. So let me do something now so that you can see. So you will see the flow of the code now. I want to just show you something. So it will help me to visualize what I'm saying. Is this program CWD environments? Here is this comment. Okay, so okay, I'm in the wrong place. Sorry. Simple shell. Save. So I want to show you guys how the program executes. So close this. So here I want to do simple shell. Yeah, simple shell. Then I want to run this. So I'm going to go to debug. Sorry, I'm going to see if I can run the program. Okay, yeah, so I can run the program. Okay, so because the process is okay, let me end this. Okay, so now I'm going to set a breakpoint in this my bin. Let me run this. Okay, so this is my program. This is the program. We have GDB. We have VS Code debugging. Let me just close this call start and just watch. So this is the same program. I try to zoom. I hope my terminal is visible to you. So again, this is the code I wrote. So this is my program. I'm running each line one by one so that you see. So this helps us to see everything, right? Right now we are at line 20 of our code and it's ended. By this line 20, we have a variable called argc, we have a variable called argv, we have a variable called env. So you can see argc, argv, env. Then if I press next, I go to this, I can be pressing next. Next is what's the key for next? F10. So I can be pressing next and be going over each line one by one. And as I'm going over each line, you'll see the variables here are changing. This is a debugging tool. So this thing you are seeing helped me to debug something that would have taken me like one day. I did it in like 30 minutes because I'm able to visualize and see where my problem, my code is having a bug. So if you know how to use this, it's good. You can do this with GDB, but if you can also learn it here, it's okay. So this is where I'm checking if. So let's say you know how you want your function to work, right? So I go. This is arty now. It's going to be one. It's going to be something else because I have not passed anything into the terminal. So if I press F10, it keeps. It doesn't run this. It just keeps. Then this is where it prints something. So this line of code now is going to write something on the terminal, right? So if you are looking at this place now, if I press here, you see that it has appeared. So this thing enables you to run your code line by line to see it. So now it's giving me a prompt to type, I think. Let me say /bin/ls. Okay, so it gave me a prompt to type, right? When I run this line, it gave me something to type. When I typed it, it came back to the code. So as I typed this thing now, this thing is meant to be stored in buff. That's what getLine, you should store it in buff. And if you go to buff, you can see it is stored here. You can see what I type is stored here with the new line at the end. Look at the new line. I hope you can see this new line because I press enter. The new line is there. Then here I'm checking if byte is equal to. So this did not fail. Therefore, all this code will not run because there is no failure here. So if I press next, I expect my code to jump from here to line 49. So if I press next, it jumped to line 49. Why? Because this does not work. There is no error, so it doesn't need to run this. So here I'm checking if the last character is /n, and as you can see here, we have /n at the end. I hope this is visible. I hope it's not so dark. So I want to replace this null terminator with the new line with null terminator. So I'll go to next. Now any line that you are currently in has not been executed. For example, I'm in line 50. What it's telling me is that, hey, I am about to execute line 50, but I've not executed, but I am about to. So right now it has not changed it. It is still new line. It will only change when I go to the next line. So we'll be looking at this place. You see now it has removed it. It's just /bin/ls. That's what this is doing. So after here it splits strings. Now I have a variable called args. Like look at this args. This variable right now is empty. It's just a double pointer. It is empty. Now I want to call this split string to separate my code into words. So I call it. Then be looking at this place. You see it has changed now. Now it is pointing to the first pointer because this is a double pointer. So it's pointing to the first pointer. Right? And look at this. These are just some information of it. It is pointing to the first because this thing I type has only one word. So this one I'll still explain this. This is like the last one. This is what I'll just use to end the class. So this is just how I handle some of the arguments. So right now this nothing is going to happen here. So I'm checking the file status, right? So again, this line has not been run. So I'm just going to go next. So check file status is false. So it doesn't run anything. What it's saying is that, hey, it found the file. This thing I typed, the file is found. It's already found. So there is no need to be checking the path. If I put the full path of a file and it is found, there is no need to do all this allocation, all this looking for file, concatenating, join. There is no need because I already put the full path, or the path is in the current directory. So there is no need to do all this. That's what I'm just doing here. You only need to do all this if you cannot find the path. If the path that is provided does not give you the file, then you now do all this. So that's why it skipped all this code and just went here. So what I was now trying to show you now is that in this after fork, like after doing all this, right, and I get to this place where I create fork, right? Now, if I call fork can fail, right? This fork can fail. So that here I'm handling error. And if this fork fails, right, I need to exit the program. If this fork fails, I need to exit. But before I exit, I must free any memory that was allocated. So that's why I print error, then I free my vector, which is args. I free it before I exit. If I did not free this thing here like this and fork fails, there will be a memory leak in this program. Then here is now where I'm checking if the thing is a child process. If it's a child process, I'm now executing the command. So while the child is running, right, the parent, I'll tell the parent needs to wait. So as you can see, parent process should wait for the child. So I'm waiting. The parent will be waiting. I pass in the PID of the child to wait. So I explained it in last class, but you can see if you want me to explain in detail, I can still explain it here, but you can just do some research and understand it. So again, if the waiting fails, so if the parent cannot wait, still free the vector and exit. So that's just what I'm doing here. But if the child, if everything here succeeds, right? If everything here succeeds, which means, in fact, let's go here now. I'm going to press F10, right? It's going to go here, right? Now this thing is not going to run because there is no failure. So I expect it to jump to line 86 here, and it jumps. Now I expect it to jump to execute, right? Now, do you know why it skipped this line? Do you know why it skipped here now? Does anybody, do you notice that from 86 it jumped to here? Do you know why it didn't run this line? Does anybody have idea? The reason it didn't run this line is because the moment I called fork, there became two processes. If you remember what I explained in black class, there were now two processes, right? Now by default, when you are running, when I'm doing, like as I'm debugging now, by default, the code editor or whatever, or my program is using the parent process. I am not in the child process now, I am in the parent. Remember, it's like we have two programs now. We have the fork and we have the parent and we have the child. I am currently in the parent, and this is the default state for your debugger. I am currently in the parent. So therefore, this code only runs for the child, and the parent ID is not 0. That's why this thing did not run. But the child currently now is running in the background, even though I'm not seeing it. I'm the parent, but the child is running now. So because I'm the parent needs to wait. Now this only runs if there's error, but there's no error, so it will just jump to line 98. Right? When it jumps to line 98, it frees the vector, then it goes to the start of the loop again, the beginning of the loop again, and it continues going like that. So I just use this to try to explain to you, give you an idea of how to know when you need to free your vector or not, and have it in mind, because if you don't do that, there will be memory leak. If you run valgrind on your terminal and your name of the name of your file, so okay, this is true, this is my program, so I don't think valgrind will work. Wait, let me check. Let me see if this works. Dash version. Oh, it works. It works in my own program. This is my own shell and it is working. Okay, because I've handled part. Okay. Let me close it. So that's for just memory leaks. So again, this is important for you to like handle when you are doing your code. So even if you finish doing the task, you have to look, did I allocate any memory? Is there anywhere I need to free it? So just have that in mind. So let me try and round up with this part, which is handling these different things. So handling, but I've explained how I did this one, handling the part. So now implement the exit built-in, right? So implement this exit built-in. What is saying is this again. Anytime you want to know how those things are working, for example, if they say implement this, right? If you want to know how it's working, right, go to the Thompson shell, which is sh. Run it. This is sh. This is the Thompson shell. This one is inbuilt in your Linux system. Test anything you want to test here. The way it works here is the way they want you to make your own to work. So this Thompson shell that I'm in now, I cannot close it with Control C the way I used to close it. Does Control D? Okay, Control D works, but I cannot close it with Control C. The way, if I want to exit this Thompson shell now, I have to type exit, EXIT. Right? This is what I have to type. Now, they want us to implement this in our own. If I run my code, though I've done it in my own now, but before you do it now, if you type exit, like if you have not done your own, if you type exit, they will tell you no command not found. They will tell you. So you need to account for this. So how do you do this? So there are different ways. The way I just did my own is just to check if that's what I have. Let me go to here. I have something called handle any inbuilt. So handle inbuilt arguments. So what I'm just saying is I have a function that handles the argument, and then in the function which is here, so far I've done two, which is handle exit and handle env. This is the two I've done for now. So I'm using a function that compares. So I am comparing. strcmp means compare the first argument. Compare the first, in case I type something more long like exit something, right? First of all, it needs to be split, right? So compare the first argument with exit as a string, and compare the first 4 characters. I don't want you to compare. Since exit is 4 letters, compare 4 letters. So compare the first one with this, and if it is equal to 0, 0 means there is no difference. There is 0 difference. 0 difference means they are the same. So if they are the same, then handle exit. So here I just pass in the argument, and I pass in the number of arguments. Then what I'm just doing in this function is that basically what I'm doing in this function, because I'm doing 2 things now in this function. This task 4 here, they say implement exit. You don't have to handle any arguments, right? You don't have to put any number. But here later they said we should do it again, but we should handle argument, which is the status. So how does this exit work? If you go to if I exit, right? If I exit this program here now, and I print echo $? I have 0. My program exited with 0. I can specify a number I want to exit with. Let me run sh again. I can say exit 95. I exited with 95 now. If I do echo $, it shows 95. So you are not just printing. So you may think that you are just printing, like just print 95, right? But you're not printing, because you need to exit with that status code. So what I did is, if I type echo, let's say 98 for example, right, this comes in as a string to my get line. Then my function splits it into 2 words. So we have echo and we have 98, right? There are 2 words. I pass that into this function. Then again, if the first command is echo, then the second command must be a number. Anything that is not a number will give you error, or it will not work. It doesn't do anything. So if I pass in a second argument, it should be a number. But you know that number is a string, because it's coming in as a string. So I need to convert it to an integer. So that is why I use ATOI. I'm just converting the number to an integer, because if you say echo 98, this 98 by default is not seen as a number, it's seen as a string. So you need to convert it to a number. So I just use a function to convert it to a number and get the status. Then I now say exit status. So this exit, there's a function called exit. Just put exit and the number that is given. So that's just how I did it. So it handles this. So like this, I've already done task 8 and that first task together at the same time. So if you run echo $, it will give you what it's supposed to give. So that's basically what I did there. Then the env command, right? So env, now let me end with this before I ask questions. So again, if you have any question, or in fact, let me just ask question, because I feel like I don't know if you guys are following. I don't know if I feel like I've said a lot. Like any question, any part that is not clear, any anything at all. I'll soon be rounding up. I'll round up with this EMV parts. But any question, any place that is not clear? So I'm assuming that you are understanding so far. Alright. So I just explained this one. So for this EMV, right, they say implement the EMV. So basically what they want you to do is that if I open the Thomson shell, sh, if I type env, it prints all the environment variables for me. If I type env, it prints everything. And this is what they want. They want our program to be able to do this. So this is very simple. There are two ways to get env variable in your program. There are two ways. You can get it through your main function env character. So you guys know about argc and argv, but we have a third one called env, and this env is a double pointer which contains all those environment variables. It is inbuilt, it's there, you don't need to type anything, it inherits it or imports it. So I can just take this env and use a for loop and print each of them one by one as a string. You can just do that, and that's what I did there in my handle env. So I have print env, I have a function that says, so what this function is just taking in is taking in that environment variable that I passed in, and it's saying, hey, for var equal to 0, then environment variable, so iterate over each of these. So iterate over each of these and print it. And you know each of these is a pointer to a string, which means it's a string. So when you are printing it, you print it as a with string formatting, which is that %s. So that's basically what I'm doing here. I'm just printing it and it works. You can try it yourself. So that's basically what I'm doing, and like this I've at least handled that. So me now I'm still working on, I'm trying to implement this one and then see if I can implement others. So I don't know, so far is there any question maybe on anything I've not talked about so far before we end, so I can explain, then we'll end the class. Any question, any confusion, any suggestion? Hello? Hello, I'm waiting on any question, any suggestion, any addition. So I'm assuming you understand this, right? Okay, so again I still have a lot of work to do, so we'll just end it here, and I'll send the recording of the class when I compile it.